All right. This set of notes I really like because this is there's going to be something in addition that we're going to learn how to do with our trig ratios. But the first part of this is a review. So if any of you were struggling on the previous lesson, this set of notes should clear some things up a little bit. So let's go ahead and quickly review the three trig ratios that we learned. Were obviously the sine, cosine, and tangent. Oops, I actually bumped that with my pen. But sine, remember, was the opposite leg to the angle over the hypotenuse. Okay, and here you can see our angle right here. This side that is across or opposite the right angle is our hypotenuse or hype. And then this leg over here that is opposite the angle, that is our opposite leg. Okay, the cosine, the ratio for the cosine was the adjacent leg over the hypotenuse. So this same triangle here at the right, it's the same angle that they use, but now they are using this leg here. Well, this leg, remember, it is helping make that angle that we're talking about. So that makes this leg be the adjacent leg, and this is still the hypotenuse. And then you have your third and final trig ratio, which I don't know why they didn't type that in the notes here, but it's the tangent. And remember, the tangent ratio is the opposite leg over the adjacent leg. You don't use the hypotenuse at all for this. Again, it's the same angle as before as the other two. And these two blanks, this blank here and this blank here, those are the legs, representing the legs, but how do they relate to the angle that we're dealing with? And this leg right here is our opposite leg, and this leg here is our adjacent leg. And so that's what we would set up in the ratio. So that's a review. That's just like from the previous notes, so there's not anything new. I gave you guys something the other day. I did SOH-COH-TOA. And if you remember, I said it was SOHCAHTOA. Okay? Kind of like an Indian name. There's also another acronym you can use, and you guys will get a little humor out of this, and I'm sure some students may have heard this before, but some old hippie was caught by another hippie tripping on acid. Some old hippie was caught by another hippie tripping on acid. So if that helps you remember what goes with which one, sine, cosine, and tangent, then go ahead. This last little question at the bottom. It's a great question. How do we solve right triangles? Because let's think about it. To this point, to learn how to solve right triangles, you've had the Pythagorean Theorem. Remember, a squared plus b squared. I'm going to go ahead and write it down here. You got your Pythagorean Theorem. That was one way. Then we also had our 45, 45, 90s. Then we had our 30, 60, 90s. And then now we're starting using trig. Well, aren't all those ways to solve or find missing things of a right triangle? So really, there's not just a set answer for this question of how do we solve right triangles. How we define missing parts of a right triangle, doesn't it depend on the information that is given? So I would put it depends on your info. Because all of these things are ways to solve a right triangle. It just depends, what is the information? What do we know? What do we know? What can we prove? And that's what determines how we solve. So I like that question. I've never had that before, but it's a good thing to talk about. Again, some more review. Okay. we have these sine. Remember this little symbol underneath each one of these deals, that little symbol that represents the angle. They're actually naming the angle theta. That's what that symbol is. In each one of these, they want us to write their trig ratio. So this one is the sine of theta, and theta is this angle right here. Well, remember sine is the opposite leg, which is 3, over the hypotenuse, which is 13. And so that's that ratio. The cosine of theta, well, here's theta, there's my angle. Cosine is the adjacent leg. Well, isn't this leg here that is 11, isn't it helping make this angle, or it's the vertex of that angle? Well, 11 is my adjacent leg, and 12 is my hypotenuse, and so there is my ratio. And then tangent. Tangent is the opposite leg over the hypotenuse, or excuse me, opposite leg over the adjacent leg, excuse me. And so there's our angle that I've circled in red. And so the tangent of theta, okay, is the opposite leg, which is 271 over 193. And so that's that tangent ratio. Again, these were just like what was in the previous notes. So let's go ahead and go on to the next page. All right. We're going to be dealing, the thing we didn't talk about in the previous lesson was inverse functions. And all inverse means, it just means the opposite. Okay. For instance, when you've solved equations, what's the opposite of adding? When you have something, when you've got something plus something, how do you end, like x plus 4? How would you get rid of add 4? Well, you would subtract. So adding and subtracting are opposites of each other. Let's say you have 3x equals 12. Well, what's 3 doing to x? What's the opposite of multiplying? Well, it's divide, right? So those are opposites or inverses of each other. Also, when we were doing the Pythagorean Theorem, what is the opposite when you are squaring something? What's the inverse of x squared? Well, the square root of x squared. So that's an opposite operation, is an inverse. And so they got some things here. They got, for instance, in this little deal, it says 5 times 8 equals 40. Well, what is the opposite of that? Well, instead of going 5 times 8 to get 40, couldn't you say 40 divided by 5 would equal 8? Right? Or you look and see this, they switch stuff around. Well, here they're showing division. Well, if you wanted to get 40 by itself, wouldn't you multiply by 8? Multiply both sides by 8, and so you'd have 5 times 8 equals 40, or in essence, wouldn't you have 40 equals 40? So this showing you the inverse operations. Okay, well, for instance, these inverses. What I want you guys to do is, we're going to do the inverse of an angle, okay? And so what we're going to do in our calculators is we're going to take the sine of theta and we're going to do the inverse. Well, wouldn't the inverse of this, scratch that, we're not going to do this. I don't want, we're going to move on to the next thing because that's really not what I want to do. We're going to go on to the next page. Alright, perfect. Okay, well, if you guys remember the other day, one of the problems that we did together is we had sine, I think it was a 26-degree angle, and then when we set up our ratio, I believe we had x over 14. So our missing part was here in the blue circle. And then if I remember right, we had another problem later on. I think it was cosine of 65. I don't really remember all the numbers, but it really doesn't matter. But we had 11 over y. Well, here the missing part was on bottom of the ratio. And when I taught the lesson, for instance, to find x, I told you that if the missing part is ever up here, then all you're simply going to do is you're going to multiply both sides by the denominator, or in this case 14. And so what you ended up was 14 times sine 26 equals, and you would multiply that out in your calculator and you would get an answer. Or if the missing part over here with this cosine 65, if the missing part was in the bottom of the ratio, then actually what you did is you had a division problem. In other words, you had y equaled 11 divided by cosine 65. Well, there's a third place where the missing thing can be. And what's going to happen is they're going to give you some parts of a right triangle, and they're going to give you the two sides, but they're going to ask you to find the angle measure. For instance, and this could be sine, this could be cosine, but in this case, I'm going to use tangent. And then I'm just making up something. But let's say they don't give you the angle measure. Let's say that our triangle looks something like this. Okay? And they tell us that there's our x right there representing that angle. And they tell us that this leg over here is 5 and this leg over here is 11. I'm just making up two numbers. Well, so again, x is our angle, okay? And so 5 and 11 are our two legs. Well, tangent, the ratio is the opposite leg, which is 11, over the adjacent leg, which is 5, right? Now, you can see in this, look where the missing part is in this trig function. We're missing that part is where the angle measure usually is. So that's what we're going to find. Well, the way that you find an angle measure is you do the negative inverse of the trig ratio, whether it's sine, cosine, or tangent. In this case, it's tangent. So we would do tan inverse, the negative inverse, of 11 divided by 5. So let's talk through this. Again, make sure that your calculator is on or is in degree mode, because that happened to me. I noticed after I did my notes the other day that a couple of my problems I was in radians. Okay, so I'll talk you through this slowly. So what I'm going to do is I need to do the inverse. So for you guys, what you will have to do is you're going to have to use the shift key or the second key. You're going to have to push second, then you're going to push tangent. If you'll see right above the tangent button, there's a tan negative 1 right above it. So when you push that shift key or that second key, when you push tangent, it's not going to be tangent, it's going to be the negative inverse of tangent. And then you're going to go 11 divided by 5. So let's do that again. I'll talk you through it again. So you're going to go to the second key, okay, and then you're going to push the tangent key, which is actually the negative inverse of tangent, and then you're going to go 11 divided by 5. And what you should come out with is you should get 65.55. And we'll round to the nearest tenth. The first 5 is in the tenth spot. That is 5 or bigger. So our actual answer is 65.6. So that missing angle measure is 65.6 degrees. Again, these are the only three ways that your angle or your trig ratios will be. You will either have your missing part will be on top, okay, which right here I would just multiply. Okay, I'd go 14 times 20 sine 26, and I would get an answer. If the missing part is on bottom, I would go 11 divided by cosine 65. That would give me an answer. And then here, if the missing part is where the angle measure usually is, then you're going to do the negative inverse. Those are the only three ways your things will be. Alright, so we're going to do some inverses. And notice here in the notes, every one of these, they are finding, all three of these is how they're finding the angle measure. They're using, look how they're using the negative inverse. Now, what determines whether it's cosine, sine, or tangent? It depends on how the information relates to the angle in question. It's all dependent on information. So let's do some together. I'm going to do a couple of these. Okay. So they ask us to my calculator set here. But they ask us to find these angle measures. So as you can see, they want us to find the tangent of angle A. Well, to do this, we're going to do the tangent negative inverse of 0.75. So let's do that. We're going to push this. You're going to push the second or the shift key. And then we'll be pushing tangent, which would be the tangent negative 1. And we're going to put in 0.75. And what you should get in your calculator is you should get 36.86, or we can round it to 36.9. Now let's do sine. Well, we're going to do the sine negative inverse. So we will push our second key or our shift key. Now we'll push sine negative inverse. And then we will push 0.87. And when we do that, I ended up getting 60.45, so 60.5. So real quick, you do this one right here on your own. Again, remember, you've got to push the second key so that you can, when you push cosine, you're actually pushing cosine negative inverse. And then your 0.15 and enter. And when you have an answer, raise your hand with the sub, check and see if you got it right. Okay. Well, for some extra practice, you can see these three examples. They already have the answers are already there for you. What I'd like for you to do is just go ahead and do the tangent negative inverse of 0.43. And then number 4 is the negative inverse for sine of 0.68. And number 5 is the negative cosine inverse of 0.94. And see if your answers come up to be these answers right here. Okay. Which you can see, for whatever reason my pen is not working right now. I don't know what's going on with my deal. But the answers are here. So you should see that number 3 should be 23.3, 4 should be 42.8, and 5 should end up being 19.9. So see if you can get those yourself. Okay, so as you can see, they went ahead on 6 and 7. They found everything. I want you to understand how they found these different parts, and I'm just going to do number 6. But there was 3 things they found. As you can see, they found what this side is, what DE is. Then they also found what this angle was. And then they found what angle E was. And all the answers are right here. Well, I'm going to go ahead and set up some things. So, first of all, the first thing they found was DE. Well, in this problem, DE is the hypotenuse, right? And you know 2 of the sides. So, how did they find it? Well, they used the Pythagorean Theorem. They went 20 squared plus 21 squared equal whatever DE is, squared that, the Pythagorean Theorem. And anyway, when they solved it, and you can work this yourself, but what they ended up finding was that DE equaled 29. So that's how they found that. Then they went to find angle D and angle E. Well, there are several ways you can do the two angles, but let's just deal with angle D, and I'll go to red for angle D. Okay. When you deal with angle D, you've got these two sides here that were originally given, 20 and 21. Well, how do those two legs relate to angle D? Well, isn't 21 the opposite leg, and 20 is the adjacent leg? So that would be the tangent of angle D. And the tangent of angle D is the opposite leg, which is 21, over the adjacent leg, which is 20. Well, isn't D, the angle, isn't that the missing part? So they did the negative tangent inverse of 21 divided by 20. So they did the shift key, or the second key, pushed tangent, which actually was the negative inverse of tangent, and then did 21 divided by 20, and they ended up getting 46.4. Then, go to blue, they found angle E. So then they found this angle here. Well, they still used these two parts over here, so it's still the two legs, so that means it was tangent of angle E. Well, now, since I switched angles, didn't it switch what leg was what? Well, 20 is the opposite leg, and 21 is the adjacent leg. And so then they did the negative tangent inverse of 20 over 21. And when they did that in the calculator, they ended up getting 43.6 degrees. So, our last page here. I want you guys to do this problem on your own. When you think you have an answer, raise your hand. You're not going to have to find an angle measure, so you won't do a negative inverse. They're actually asking you to find sides. So, you're either going to, your answer is going to be something where when you have your ratio, whether it's sine, cosine, or tangent, when you set up your ratio, your missing parts aren't going to be here because they give you the angle measure 25. Your missing parts are either going to be on top or on bottom of the ratio, so either you're going to be multiplying or dividing. So go ahead and do this problem. When you think you have an answer, raise your hand. Let the sub check and see if you're right, and if not, ask for a little help to get direction. Okay, now there's not an assignment set with these notes. The next video, or the second video, is actually ties into what we've been doing. It's more real life, and that's where the problems will become. But this was just to kind of review and to clear up some stuff.